Good afternoon, and welcome to Elliott Astro-Imaging, and I am your host, and I just figured I would do a short little session here today in regards to calibration frames, and I'm going to go in a little bit of detail with that today. I do have all my calibration frames open, and I'm going to go in a little bit of discussion to what is a light frame, dark frame, what is a bias frame, and what I'm going to do is I will pull up my calibration frames. I have a folder here. All right, so I have the calibration frames opened up here. And what you can see is I have the Canon T3i, which is what we use at the Buffalo Astronomical Association at the Beaver Meadow Observatory. They also use the ST9, which is right here. So this is the ST9s. And the cameras that I have are the Orion G3 and the QHY9C. So these are all here. So I have them broken down into, so like if you were to go to the QHY and you would go to the flat frames, I have them sorted out to be H alpha and the Orion Skyglow. So I have them two here. So the hydrogen alpha, as you can see, I took a whole bunch of them. And the definition of is you're just going to use the camera as based off of the flat field frames are used to address unwanted problems in the optical path, including dust, dirt, vignetting in the camera, and internal reflections. Any change in the optical path, such as focal reducers, filters, camera orientations, or focus, will require a new flat field frame. To obtain the best possible flat field frames, you would need to take it in the same conditions as the lights, darks, and biases. Okay, and we'll go over the other ones in a second here. To take the flat field frames, first you need to get your telescope into focus and then point it to an evenly illuminated surface. Flat field will be taken from the twilight sky, or I have an LED flat field panel that is used for an artist sketching or drawing, and it hooks up through USB. And you just point the telescope directly at it. You take 1 to 2 second images until you get that histogram to be exactly dead on. And what I mean by that is if you were to go to one of these, I took the OSC, which is the one-shot color. So if I were to double-click this, and I'm going to pull this up here, I'm actually going to do entire screen so that way everybody can actually see it here. So if you were to do the flat screen here, you actually see it's a white image, okay? And you actually look on the right-hand side, there's a bump in the middle, and that's what you want. You want that bump to be as close to be as possible, so this way you're getting that. So if I were to take the left one and bring it all the way to the left, you can start to see dust motes in the optical train. You want. No telescope in this world is going to be absolutely perfect unless it's brand spanking new. And even that, there might be some dust motes and some things in the optical, whether it be the camera, the telescope, or the filters that you're putting on there, you're going to get some. This is extracted from the red channel. As you can see, OSC R flat. It's a one-shot color extracting the red channel, and that's what I use for my hydrogen alpha. I also have another one set for this Orion Skyglow, and you have to go through each image. You're going to see little circles, little dust motes, and that's fine because what happens is if you don't use the flat field or the flats, these will show up in the images, and what this will do is it from the image itself, so it'll actually be a flat image. Hence, that's why they call it a flat. And I usually take, when I do the flats, whether it be the hydrogen alpha or the Orion, and then these are just the unbayered ones. These are just regular, and you can see it from there, which is kind of cool. And then I have the Orion Skyglow here. I might redo them because I like to do them every year. I took those in July of 2015. Yeah, and what it does is when you stack them each individually, it creates a master flat. So it actually stacks them and creates an average, which is what you want. And an easy way of going through each flat individually, and I can show you how to do that, is you go to File, Preview Files. I'm actually going to get this bigger here, so there we go. And you go to Load Images, okay? And then what you want to do is you go to Calibrations, and you go to Flat Files, and you go down and you click all of them that are the OSCs, and you hit Open. So what it's going to do is it opened every single one of them, and you are going to look through each and every single one of them to see which ones are good, which ones are bad. So there's one, there's another, and you can see that the images are changing just a slight bit. So in case if there's an image that's on there that isn't great, and sometimes something might get in the way when you're taking the flats or whatnot, but I went through all of these. These ones should be fairly good, and that's what you have to do, is get it as close as you can to that bump, to that middle. What that means is if you're going to take a 1 second image, see where it is on the actual histogram. If you're to take a 3 second, it all depends on distance. You can keep it at any distance possible. If you want to put it as close to as possible, if it's a low light, fine. If you want to do it as they said, the dusk, the twilight sky, you can always do it that way. Some people even put a white t-shirt over it because that's a flat field. So you could do it either way. So that is a little tutorial on flat frames. Okay. The next one is darks. And I went over a little bit about darks with that too. Darks is pretty self-explanatory. The purpose of dark frames is to remove the non-image related thermal and electronic noise of the CCD generated when capturing the light frames. And light frames are what you take on a nightly basis. That's where the objects, okay? It also removes imperfections of the chip, such as hot pixels. Since we are the buildup of thermal and electronic noise, it is important to match the dark frame to the same conditions as the light frame. This should include the same duration of exposure. So what that means is if you're going to take a 10-minute image of Orion or a 10-minute image of the Hercules cluster, you're going to need a 10-minute dark. So usually if I shoot 20 to 25 images, I like to get 5 to 7 darks. It's about 25% of what you're shooting. The dark frames can be taken by covering the telescope and as it says, take 15 to 20 images of the same exposure length as the light frames. With these dark frames, we can generate a master dark frame. So if we go to the QHY9C and we go to hydrogen alpha, you can see that I've only taken 5 minutes and 10 minutes. I did discuss in the last episode that I need to take 8 minutes. I'll be doing that tonight to get the 8, and I'll also do a couple of 6s, and I'll even do some 12s too. So this way, if I decide that guiding is going really well and I want to shoot a 12-minute image, boom, put the 12-minute darks in there and you're golden. So I have the 10-minute darks. I only have 3 of them. What it looks like when you double click it, it goes through nebulosity. You can see that there's noise through here, and that's fine. That's what you want. So you can see there's actually noise in the image. And again, that's fine. That's actually a pretty good image for 10 minutes. I'll show you one that is the 5 minutes. So you can see not as much noise because it's half the exposure time. And you can even see the ones that are in red too. That's what this one is here. This one is actually reconstructed, so it's actually a red image. And we'll actually bring this one over here. It's a little bit red. It's actually in color, and you can see it, which is really neat. And you use those without the extracting the red. So if I want to do hydrogen alpha without the red channel, you would use the reconstruction on those. And you can see that it created a master dark for this one too. With the darks, I like to do them every 1 to 1.5 years. As the more images you take, the camera will change with exposure. So I like to try to keep it within 1 to 2 years. I took these darks in May of this year, so by next May, next June, I will create a whole nother set. The other problem is if you have a DSLR camera, With the DSLR cameras, what happens is you have to, where I was writing things down and I forgot to mention it, is with the DSLR camera, you have to use the same temperature settings. With the CCD camera, you can set the temperature at any night. I usually like to set my CCD camera at 30 below 0 Celsius. You cannot. It's not a CCD camera. It's not a cooled coupling device, and it does not have the TEC, which is the thermoelectric cooling. The DSLR will run anywhere from 70 degrees in the winter, Fahrenheit, sometimes even 60 on a cool night, to 100 degrees Fahrenheit on a hot summer night, because it does not have any internal cooling. So your darks are going to fluctuate big time. So on a night like tonight, where it's going to be 90 degrees during the day and 70 at night, your camera can range anywhere from 100 degrees to 140 Fahrenheit. So you're going to need the darks between that range. And it will save that when you have backyard EOS temperature. So you can be able to use the darks within that range. And 5 to 6 degrees, no big deal. But you don't want to use darks that are 65 degrees for one that's 140. It's just not going to work, because the darks are subtracting from the image and the thermal noise is going to be completely off. And you definitely don't want to do that at all. So when you're done with that, then you'd be able to just take those and put those right into Deep Sky Stacker, and you'll be set with that. The next one that we use, and I want to describe, is called the bias frames. And with a little bit of description on that, I wrote it down, is when using a CCD chip. Now, if you have a DSLR, it's completely different. But when you use a CCD, not all the pixels start out at a value of 0. The purpose of a bias frame is to apply it to a dark and a light frame to bring out all the pixels on the CCD to an equal starting value. To make a bias frame, cover the aperture or corrector plate in the same fashion as the dark frame. Capture at the lowest possible time setting your camera will allow, meaning that you want to get the absolute fastest. You want to go lowest, meaning the fastest. So like if you have a DSLR, do 1/40,000th of a second, okay? Or if you have a CCD, do 1/100,000th of a second. So you want to get it as fast as you possibly can, so it'll just keep cranking them out one after another, okay? So if I look at my bias frames here, I have actually I just shot some of these last month, but I do have these, and I did extract them here. It'll say 0 milliseconds. The 0 milliseconds, it actually doesn't even register on it. I put it as 1/10,000th of a second. So it's fast, and that's what you want to do. So that will actually work out perfectly. I took 8. Also, it says bias frames should be taken at the same temperature and settings as the light frames. Like I said, same thing with the dark frames. If you have 70 degrees on your camera, you want to take 70 degrees all the way through, okay? And then it will also create a master bias frame, which is right here. So that will be set there. So this is a little crash course of looking at it. And of course, I have the ones for the Orion too. Same exact thing. So gives you an idea of the calibration frames. So I want to thank everybody for watching.